Should be fine. Today, only on Twitch you can talk. I mean, you can chat with me. I turned off the YouTube stream to be able to focus. If we hit complete problem set here, we will go through those 6 problems. Row GCD? Yeah, we will talk about row GCD. But it will be just in this order, you know, A, then B, and so on. Let's start. A is anyway easy. I don't need Endagorion for this one. You can join me whenever. Big difficulty jump from A to B, I mean in division 2. All right, problem A. We will go in the order. Let's quickly be done with A. There are red and blue numbers written on cards. You need to shuffle the cards, and then you care about the big red number you get and blue number you get. You care about which of them is bigger, and you need to say something about probabilities. But important observation is that in every number, the exact value doesn't matter. If you have a card and there is number 2 and number, say, 5, it is the same card as, let's say, something else with 0 and 1. Even zeros don't matter, whether it's a 0 or not, because they said leading 0 can be treated as like literal 0. Doesn't matter. That was supposed to be blue. Those 2 cards are equivalent. So every card, it's just important whether blue is greater or red is greater or they are equal. That's because once you put all the cards in the order, like this, and Endagorion is writing to me. Can we solve C using segment trees? Let's try to keep the conversation to be about, you know, the current problem. Endagorion is trying to join. I was saying that, yeah, when you put cards in order, there will be some tie, maybe, in the prefix. And again, doesn't matter what values here are exactly. And after this tie, you just care about the first moment when the digits differ. And which one is greater, it defines which number in total is greater. Hi there, let me put, we are live already. Let me put your face in the stream.
Hi.
The contest went smoothly as planned, no technical issues?
Yeah.
Cool.
Yeah, pretty good.
All right. I think now everybody can see you. Again, Endagorion is one of the authors of this contest, and generally very experienced problem setter and participant. Which problems were yours?
Well, actually, I'm the author of, like, in the Codeforces run, all problems are mine, and other authors contributed to the ByteDance online contest.
I see. Okay, so all the complaints should be to you.
Exactly.
You're the one
yes.
to blame. Okay, great.
Yes, I can guess you must be pretty cross with me right now.
Well, it's generally true that the better you perform, the more you like the contest. And the exceptions are just very...
That's true.
Some problems where then somebody tells you one sentence and, oh, it's like that. And then you must admit that it's a good problem. But yeah,
Oh, we'll see. We'll see how it goes.
yeah, we'll see. The plan is to talk about all Division 2 problems, so everything up to flip and reverse, because then I didn't spend more than 1 minute on anything else. So we will not touch that, and also I will not comment on them. Let's be done with A, because I started saying something, and I will finish in 1 minute. We'll move on. Red, blue, shuffle. So yeah, the first card where there is a difference, it matters, and then we can say, in this case, if this is 6, this is 4, then blue number is bigger no matter what is there on the right. So what matters is only the number of cards where blue is bigger, red is bigger, and ties. And fortunately, they didn't tell us to compute the exact probability, something like that, just say which one is more likely to be bigger. And because the only difference between them are those cards with blue bigger and red bigger, then just you need to compare the number of those cards. Whether there are more cards where blue is bigger. Is that right, by the way? I didn't implement.
Yeah, that's correct.
All right. I don't think chat will want to spend some more time on this. Any comments about the creation of this problem? The origin or something?
Oh, well, it's hard to create a good, easy problem, as you must know probably. But as for this problem, I'm like it certainly was harder than usual, probably because it was just more unusual. Usually, div A is just implement something that you're told, but here, like we consciously went with this unconventional problem because like it involves some probabilities. However, a lot of you don't need to know about probabilities a lot, because a lot of the argument can be done sort of intuitively, right? First, you notice that cards with the same numbers are not important, and then it's just the problem of like which is more frequent.
On the one hand, you indeed don't need probability computations. On the other, in any kind of problem like that, if you don't know probability well, you easily can make some incorrect lemma. So then if somebody is bad at math, they can solve this problem, but they will not understand it fully, maybe.
That might be true, yes.
There were a lot of discussions on easy problems in past months on Codeforces, because Anton gives a lot of ad hoc problems or mathy problems, and that's the opposite of those where you just need to implement what you're described in the statement. There are a lot of arguments on both sides there.
Yeah.
All right, problem B. Move and turn. If I'm correct, so please tell me if I'm wrong. Every second step needs to be horizontally, every second step vertically. It doesn't matter which one is first. I mean, we can decide. And after n steps, so there will be n over 2 steps in one direction, like say ceiling of that in the first direction, floor of that in the second direction. After that, so that many times you can move, let's say, up and down from the beginning. Let's say up, up, down, and that many times right or left. The order doesn't matter because we care about your final position. So let's say right, right, we moved. We could be here after 5 steps. 3 steps we spent horizontally and 2 steps, 3 vertically and 2 horizontally. We need to count the number of points where we are at the end. So from n we get those 2 values, and they tell us how many steps we get in each direction. And that will tell us a rectangle where we can be, with exception of parity. Am I right so far?
Yeah, pretty much.
All right. If you, maybe a new bigger drawing, if you make, say, 5 steps, then after 5 steps you could be 5 above the origin, or you could be 3 above, for example, by making 4 up and 1 down, but this can be in any order, can be up, down, and then ups. Then I claim we can be anywhere here. The parity must match, because after every even number of steps you must be in even position. You can be anywhere here, and that doesn't, it is independent from moves horizontally. And if n is even, then this is easy because you're just given information about the number of steps vertically and horizontally. That's some rectangle where every fourth point is allowed because of parity. So if we properly round things, it will be area of rectangle. Like you need to expand this rectangle by 1 in each direction, maybe in each, like horizontally and vertically, then divide by 2, then take area. And if n is odd, then just it will be twice some number, because horizontally or vertically we take the bigger one number of steps. That would be my solution.
That's true.
Right. Chat, any questions about this? And any comments? Endagorion?
Well, really not much to say about this problem. You could find a pattern like this with some reasoning, pretty much the same one as you explained. Since n is small, you could also go for some like try coordinates, for example, an x coordinate where you can arrive and then figure out the range of how many steps you can make vertically possible. So we didn't try to force the formula on you. You could try to go for different approaches.
Okay. To those asking, to those telling in the chat, yes, for sure, you can figure out the final formula related to n squared in some way. It will be n squared divided by 4 times 4. I don't care. I didn't go through the formulas. It will be something like that. What's important is of course the way you derived it. The idea is if n is 6, then you take 3 steps horizontally. So you can be here at 3.0 if you skip the vertical steps, or you can be in one of those red points in terms of your x coordinate. That's from -3 through -1 plus 1 plus 3. Same thing happens vertically independently in every second step. So actually those will be allowed points. And you can compute the number of them by taking side square in this case. This, yeah, should be good. Here should be what, 5 times 4? That's suspicious. I messed up. 1 step you can make vertically. All red points should be now shifted by 1 down. Sorry about that. Or maybe I will make this trick. Here we go, 16 points. And 16 is for square. It will be related to n over 2 square. You can figure out the formula. All right, let's move on to interesting problems. GCD is something that I didn't solve in like a minute. I needed a few minutes to come up with a solution. Is it fair to say that the statement should say there are queries?
Yeah, you can treat them as queries.
Is the solution offline? I found it strange, this input format, where instead of saying q queries, they say m integers for each of them do something.
Yeah, really no justification for that particular format. So that I think I had in mind that you could construct a matrix with AI plus bj as an element of the matrix, and then I just didn't see it through. So that's that's what it came to be.
When I first read this problem, I read it again because I wasn't sure if I understand correctly because of that.
I see.
Indeed, it makes sense when talking about matrix. We have values A1, A2, A3, A4. We have B1, B2, let's say B3. Both N and M are up to 100,000, something equivalent to that. In every cell of this matrix, you put the sum of corresponding values, AI plus Bj. And you need to find GCD of every row. But you cannot get the whole matrix and run GCD function for every next value, because that will be quadratic, so too slow. And this is problem division 2c. Right? But whenever you have, but those values in one row, they are very similar to each other. Like in every row, you know that the differences between them are constant. You're given once this sequence A1, A2, A3, A4. You know that every row is similar because it's related to that difference. If A1 is, say, 7, A2 is 9, then you know that whatever value will be here, maybe 16, then it's 18 here. This is greater by 2. So always, if left value is even, this value is even as well. So here we have some divisibility in common. On the other hand, if this is no matter what this value is, this isn't divisible by 3, like 2. They cannot both be divisible by 3 because the difference is 2. The difference of values AI, red values in the drawing, they tell us what could be possibly GCD of those greater values because the difference is the same. If you want two numbers to be divisible by x, their difference is divisible by x as well. Will that be the only solution, by the way?
Mm-hmm.
All right. Then, yeah, formally using some math notation, you just need to, we use this fact, GCD of A, B is equal to GCD of A and A minus B. This is what you use in the Euclidean algorithm at all, like to solve GCD. A minus B can be B minus A, whatever. This is true. So GCD, I will just type G, of some value B plus A1 and B plus A2 and some other values, it's equal to GCD of B plus A1, the first value in the row, in blue row, comma, A2 minus A1. And we know this value in advance. If you put now value 3 here, I will copy this whole line and just used 3 instead of 2. Then it will be 3 and a 3. And this value we know as well. You can make a lot of rows like this. And you will find this way that you just need GCD of B plus A1 and all those differences that you know in advance. A2 minus A1, A3 minus A1, and so on. So the solution is, before reading any B, which are basically queries, take A2 minus A1, A3 minus A1, A4 minus A1. You could also take differences of consecutive values. Maybe even I did that. Don't remember. Compute GCD of those n minus 1 values. If maybe this was 15 and this was 5, then here we would take GCD of 2, 8, and 2. That would be 2, a big precomputed value. Let's remember that. And for every B1, we just need GCD of B1 plus A1, the first value in the row, and the precomputed red value at 2. And then we print GCD of B2 plus A1 and 2, GCD of B3 plus A1 and 2, and that's it. The whole thing will be linear times logarithm because using GCD is logarithm.
Yep, that's the trick, exactly.
I remember that first I misunderstood this a little bit, but I don't even remember how because I resolved my issue in 10 seconds with samples. If you do it brute force way, it will be quadratic at least, so you cannot make it pass. Chat, questions? Can we use DP for it? Oh, I remember what I thought at the very beginning. I thought whether Pollard's law is possible, whether it passes in limits to use n plus m multiplied the complexity to find all factors of values. So that's it's treated as value to the power 0.25. I'm not sure if that's exactly the complexity.
Yeah, something like that.
Is it possible to solve problem this way? Do you know that?
I don't think so. The intention certainly was to only use GCD instead of fancy factorization algorithm. And like on a test with you can construct a lot of tests against factorization solutions. Like for example, a product of two large primes works pretty well. Or if you want to utilize that the number of divisors is small, you can just have a test with a lot of different divisors.
Yeah.
So I think we tried most of these solutions and none of them worked.
All right. Chat says, sadly, this was Googleable. Yeah. Problems with very short statement are cute, but on the other hand, from time to time you will have a Googleable statement. There was something on Quora about it. If G is the GCD of n numbers and each number is then increased by some positive constant, what is the fastest way of calculating GCD? Right, so they have some sequence A and they say everything you increase by X, what happens then with GCD?
Yeah, that's
Indeed,
true.
it's equivalent, but I believe it's hard to think about this version of the statement and Google it.
Yeah, we tried to Google the exact statement, but we didn't go to too much effort. I guess you could, well.
Oh, happens. Happened to me too.
Yeah.
With my problems. Should we move on to D? Glass half spilled.
Okay.
For people who just joined the stream or something, we will go through all the division 2 problems from A to F, and we are now at D. All right. I like the statement of D. Maybe not extremely natural, but like I saw more natural problems, but still it's something not very mathematical in terms of what is described. Is it a real life problem where you had like 10 glasses and you wanted to choose 3 of them to have maximum amount of water?
Well, like I won't swear for the exact numbers, but I could imagine a situation in real life where something like that could happen. And spilling water is certainly something I do a lot. So.
Right. Somebody is repeating the question, can we solve B using recursion, the move and turn? It's a very mathematical problem where you just, at the end, print the product of some two values. So
I mean, you can use recursion to find some small values and then look for a pattern if that helps. But like the actual solution is going to be either a pattern or something else.
In cubic complexity, you can just run like any kind of DFS where you know where you can be after n steps. So
yeah, cubic probably won't work as well.
Maybe a very fast cubic solution will work. Like it
could be. You could also try to like go over different x coordinates and apply some rules. Yeah. Maybe if you don't have a complete pattern but you have some ideas, then you could have a quadratic solution of sorts.
Yeah, but for sure not the easiest solution.
Yeah.
For D, I will tell you that I thought that it's some kind of parametric search first. The trick from Aliens from IOI.
Oh yeah, that's what that's what made me interested in this problem, because if you have a statement like that, you immediately, like if you're experienced, you immediately start to look for, okay, what kind of comparison can I use to sort and like use greedy and stuff like that. But nothing worked, and I spent a bit of time with these kinds of solutions.
I even submitted something like that, and indeed, I got wrong answer.
Yes.
Which hurt me a lot because I didn't solve anything else, so I had only 2 problems. So in Division 2 it would be C and D, and everybody else were faster there. In very short, I will just tell it to you without explaining in very detail. What I got is that we have a bunch of points and we need to choose some of them to maximize how far we get on this line tilted by 45 degrees. Do you see the stream? Do you see my screen?
Yeah, it's a little bit delayed, but it's okay.
It should be several seconds. So it was something like that, where this coordinate from which the line starts is the sum of all b values divided by 2, I believe. And then all points, if we sum up points up to anything in this red area, I mean 2 red rays, they will give the same value, which is just how high we are on the blue line. I had those kind of thoughts, and I came up with some n cubic times logarithm solution. I implemented, got wrong answer, then understood why it's wrong. Yeah, I don't think.
Yeah. It's very like it's very natural to think along these lines. This was, I guess, pretty intentionally a trap problem for experienced competitors.
Sometimes it hurts to know more.
Oh, I feel you.
All right, then let's talk about the full solution. Dynamic programming is the only way to do it, or not?
I think so, yeah. So in a nutshell, this is pretty much equivalent to a backpack problem, a variation of a backpack problem. So probably can't do any better than dynamic programming.
All right. Yeah, we have those glasses, and when we choose some subset of them, there are only few values that are important, some sums that are important. Let's go full screen, and this is problem D. We have those, and we choose these 3 glasses. From other glasses, I just care about the amount of water in them.
Yep.
Let's call this value water outside. I used other names, but here can be water outside of the chosen set. In the red chosen set, we have water inside, water that we already have, and we have the amount of space available. And you can maybe think about that left space, but for me it was more convenient to think about the total space. Let's call it sum of space, SS. This is total space allowed. You cannot have more than that. And if you have those 3 values, you will get answer from that, because the maximum amount of water you can have is water inside plus water outside over 2. From everything from outside, you divide by 2 when getting here. And this needs to be minimized with the space you have. Now, did you transform this formula some more, or did you go with this? Do you remember?
Well, you have the total amount of water, right? So that would be like W.
But did you subtract here something, or went with the total amount of water over 2? I think those are 2 possibilities.
I mean, it helps a bit if you want to work with only integers. You can multiply everything by 2, so that you don't have to. You always divide evenly. But other than that, no, pretty much the same formula.
Okay, I will copy this, paste to another slide. All right, those values are important, and indeed we know the total amount of water. So W in and W out are very much related. If I tell you 1 from my chosen set, then you can compute the other. Forget about this red line. Like if total amount of water is 20 and I tell you that water inside is 7, then this is for sure 13. Using this, we can replace something here. I went with saying that this is W over 2 plus W in over 2. So this should be equivalent formula.
Yeah, that's correct.
Because W over 2 is W in plus W out over 2. So this part you can replace with in plus out. And then W in and W in, they will be reduced. So we know that. This is pre-computed. And from your choice, you only care about this and that. And total space you have is the sum of what value was bigger? This was A.
This was B's and A's, right? So A is larger.
The A is larger. Okay. This is sum of AI of taken glasses. This is sum of BI of taken glasses divided by 2.
Yep.
And this is like two-dimensional knapsack where you get every item is described by 2 values, A, B. And at the end, you care about the sum of A's and then sum of B's. So instantly you get solution in complexity, maybe in white, in slow complexity, n multiplied by, let's call it x squared. X is the sum of values. X is n multiplied by max value, which is here 100. 100 denotes max AI or max BI. If we just did knapsack where we remembered that sum of A, sum of B. And that's too slow. That's slow. All right. Do you want to tell us the next step?
Well, the next step is, like in dynamic programming, you usually can, if it's too slow, you can try to like flip the values that you compute with parameters and vice versa. So in this formula above, where it's the minimum of 2 values, right? So for a
in this one,
yes. So for a fixed, for example, if you have a subset, we know the number of glasses, and we know, for example, the total capacity, right? So the sum of AI.
Okay, so we know this right value.
Yes. So we don't care exactly which sums of BI are reachable. We only care what's the largest value, right? Because if the value is larger, then the minimum is, well, it's at least not smaller. So it makes sense to only think about the largest value.
Exactly. Like if it's possible for you to get the sum of A's 17 and sum of B's can be 10, 15, or 20, you just take 20 and you move on. You don't need to consider those lower cases. When you do Boolean DP, actually in complexity, I forgot that we also need to know the number of taken glasses. So for a moment, let's say that I don't care about the number of taken glasses, which is not true. And at the end, complexity is actually multiplied by n. So to simplify things, this is stupid DP, Boolean DP, where you have knapsack and you care if this sum of values is possible and among the first I elements. But among those 3 dimensions, one of them you can move outside if you can say that you just want to maximize it or minimize it. And here we can move either of them. Let's say we move sum B. Will that match this? Yeah, it matches. So I get rid of this last dimension. And instead of bool, I say here int. And the definition of this DP is for this state, I and sum A, the maximum possible B.
Yep.
And thanks to that, the number of states decreases to just O of n multiplied by this sum of A, which previously was denoted as S. And that can be at most n multiplied by 100. I denoted that as x, but let's fully write it n multiplied by max A. That multiplied by n if you care about the number of taken elements.
Yeah, so now we just need to add an extra dimension that accounts for how much glasses do we actually include in the set, right? Because we need to separate different possible answers into groups and then take the best answer in each group.
The final thing is DP of I taken and sum A. Taken is the number of taken elements. Transitions are just like in any knapsack. From this state, you consider taking the next element, and then I increases by 1, taken increases by 1, sum A increases by AI. And this should pass, I think, space-wise, right? It will take 400 megabytes.
Yeah, I guess it's not impossible to pass, but I think you're going to tell us how to reduce the memory complexity as well.
Yeah, if you directly compute how much space this uses, it will be 100 million times int. Maybe short would be enough.
Maybe.
Yeah, short would be enough. Then
probably.
it will be 200 megabytes. Should also be maybe a little bit faster. Assigning a lot of space is slow-ish, and also maybe this would be more cache friendly. Hard to say. But you just can get rid of one dimension. If one dimension is as easy as just always moving from I to I+1, this is usually you call it moving row by row in DP. Then you don't need to remember all the rows. In knapsack, basically, you don't need this first dimension. Just if you don't know it, think how to solve knapsack without having I as dimension. And it's described.
Yeah, the idea is.
Yes, continue.
The idea is basically as you increase I in your computation, right? You can deal with overwriting elements as I changes, right? Because you don't need alt I's anymore.
Exactly. Just sometimes if you don't want two rows, if you don't want, there are two ways to deal with that. One is the first dimension can be of size 2. The other is, I can show my code. Yeah, I just made sure to go in proper order via states, taken and the sum of A. Taken I needed to do decreasingly, otherwise that's knapsack where you consider taking the same item multiple times, which makes sense. In some other problem they could tell you that the glass can be taken as many times as you want. Maybe it would make the problem easier because of other observations, I'm not sure. So, to everybody watching, you can make a screenshot now and think about this code, or just go to my submissions. This is knapsack without that extra dimension. Can you give test case for which greedy would fail? That's the question from chat.
Oh, I thought it could be difficult because sometimes you have to construct pretty intricate tests against greedy. However, I found that in this case, you require a lot of different answers, and you have to get all of them right. So actually, most random tests like fail every greedy that I could think of. But there are also some handcrafted tests with particular answers.
The test would be weaker if you gave k in the input, the number of glasses you want to take. Solution would be the same, but you would just print one value and it would be easier to hack it, maybe with something greedy.
Yeah, exactly.
That's a good point. That's actually the worst in yes or no questions, where the output is just a single bit, yes or no. Then it becomes harder to create tests, because a random program would have 50% probability to pass tests, to pass a single test.
Yes, well, that actually used to be a big issue. I am not sure if you were around at that time, but like in IOI-styled contests and like in Russian National Olympiads, for example, it used to be that you receive score for each test individually. And so if the answer for each test is yes or no, there's a pretty easy strategy that gets 50 points in expectation in this problem. So that was the reason for introduction of subtasks in IOI style.
Or something maybe a little bit equivalent to subtasks would be multiple test cases, which is now mostly used just to speed up the judging in Codeforces, for example, if there are multiple test cases per test file.
Yeah, well, both are used, like often in combination. So at least now we know how to deal with that.
All right. Problem E. Also, chat says, is there a faster solution than n cubic times a? Is there?
I'm not sure. Like, if you look really closely at this problem, it's equivalent to knapsack. So if you're able to provide a faster solution for this problem, you'll be able to solve the knapsack faster.
I don't agree, because we care about the minimum of 2 values at the end. So it's knapsack where from the final states we just care about the minimum of one dimension and the value stored in DP.
That's true. Well, I don't have like a strict proof for this, but I think if you construct the construction very carefully, then I'm going to say, okay, I guarantee you that the answer is actually the sum of b's in the subset that satisfies certain certain constraints. So it's like it's not straightforward, but I think a reduction is possible.
All right. If reduction is generally a way to prove that one problem is not easier than the other.
Yeah, exactly.
Yes,
like
maybe this can be proven
in complexity analysis, you do that a lot. So you say that if I can transform the input for one problem to the input for the other problem, that takes no effort. So one problem is just as easy as the other.
Almost every NP-hard problem you just prove by doing reduction from FreeSat or to FreeSat. I don't remember the word for that.
Exactly.
Basically take FreeSat.
That's a common trick, yes.
Latin square. Now, on problems E and F, I spent a little bit of time and mostly on F. So in E, you will need to basically tell us a solution. First, we go through the statement.
Okay.
Anyway.
All right. So this problem, we had this Latin square that's a common object, I guess, that's studied in discrete mathematics. Like if you like to solve Sudoku, then a Sudoku is a Latin square, right? So the constraint is we take a square matrix, right, n by n, and we place numbers in each element so that if you look at each row, then it has all different numbers from 1 to n. So in this example with n equals 3, you can see that each row contains 1 to 3 in some order, and also each column contains 1 to 3 in some order. Like if we had Sudoku, there would be additional constraints, but this is enough for us. Okay, so we're given this Latin square as an input, and the problem is basically a simulation problem, right? So we are given some instructions, which manipulations to do with the square, and we have to output the final result. So the manipulations are, first of all, we can shift the square in all 4 directions. So for example, moving the square to the right would mean that all elements go 1 step to the right.
Then I believe I can move the last column to the leftmost position or the other way around.
So if you move to the right, then all elements move to the right except the elements that have nowhere to go. They instead go to the first column.
All right, so this is the first possible operation. 3, 1, 2, the last column moved to the first position, and the next operation will be symmetrical, just in the other direction.
Yes, next operation would be to move to the left, which is just really undoing the operation of moving to the right.
Okay, next two are same, but for rows.
Exactly, yes. The next two are the same, but vertically. We move rows down with looping.
All right, and all of that would be easy because that just I would just treat rectangle as a torus, and I would shift a single offset.
Exactly, yes. You just need to care about the offset. But the last two are kind of tricky because now what you can also do is an instruction can say, okay, we look at every row, and we know that every row is a permutation, right? Numbers from 1 to n. And we are instructed to replace each permutation with the inverse.
Yep. Inverse, meaning that now instead of for every position we want to know the value, it will be for every value we want to know the position. So in the second case, on the first position, here we want to create a new grid to 3 by 3, here I want to say in this row, where was 1? Well, 1 was on the third position. Where was 2? On the first position. Where is 3? On the second position. This is the inverse of permutation to free will.
Yes, that's the intuitive way to think about it.
2, 3, 1. Okay, so that would be the thing if we did for rows.
Yes, and the other last kind of instruction is that you do the same thing, except you read permutations vertically instead of horizontally.
All right. And if we get back to the statement, what we need to do is simulate it faster than with brute force. Grid is 1000 by 1000. If we did every operation with brute force, it would be number of queries, m, 100,000 multiplied by 1000 square, size of the grid.
Exactly, yes.
That's too slow. Somebody told me something in chat, an idea is shift of an inverse of some shift. Is that true? Okay.
I mean, there are certainly relations that you can find between inverses and shifts. I think what's interesting here is the general picture. There is a certain way to look at things that make the solution really clear and simple, I guess.
Then I don't know anything more about the problem, and you tell me a hint or a solution.
Okay, so well, you actually made a good point about how can we solve the problem if we only had just shifts, right? You only store the offset. And offset can be updated in constant time, and after that we apply the offset and like output the metrics sort of in a different set, in different system of coordinates.
Okay. In other words, I would just say that we have bottom top left corner, and when I want to shift everything to the left, right, up or down, it just means moving this corner by 1 and treating the thing as a torus. This corner being here, it would represent that this is top left corner, then this full first row would be this cell, and then blue, this next blue, next blue. That would be the first row. That's the easy part.
Yes, exactly. You just keep track of where the red point is, and then you know everything about the square. Okay, well, so that's clearly not enough for the inverses. However, what helps is to, okay, instead of the actual square, let's look at the set of points, but these points are going to be in 3 dimensions. Right, so when we have an element in the cell ij, right, so in ith row and jth column, and it's equal to k, then we think of it as a 3-dimensional point that has coordinates I, j, and k.
Right, and then inversing is swapping 2 dimensions?
Exactly. When we apply inverses to a row, what happens is for every point, the first coordinate stays the same, and the second 2 are swapped.
Whoa, well, that's a nice observation. I'm surprised that I never thought or heard about thinking about inverse like that. Maybe I did, I just don't remember.
Yeah, it's not very well used, but it's nice.
It is. Okay, so we need to be able to swap third dimension with one of the first 2. Well, in particular, we can be told about swapping first with third and then second with third. So
yes,
effectively, first with second also can be swapped with 2 operations.
Yes, so with these 2 operations, if we think of them as swapping 2 coordinates, then we can basically get every permutation of the 3 coordinates.
Right, then I just need to maintain a permutation of dimensions, like which one goes where.
Yep.
Like if at the beginning it was ABC, then I need to know that, for example, now it's CAB. And there is a thing with increasing something by one, well, modulo n.
Yep.
Wait, is that it? Will that problem be... Are we done?
Well, basically, yeah. The last thing to consider is how do we output the answer, right?
Yeah, to output the answer, we go through all n square. I would create a grid, the two-dimensional one. I would go through all the points, and every time two of the three values, they denote coordinates in the grid. So take them and put the proper value there.
Yep.
Okay.
That does it.
That was surprisingly easy.
I guess.
That's a very, very, very nice problem. Wow.
Yeah, I'm quite happy with it. The only issue is that we might have underestimated its difficulty a little bit.
I can't really say because I spent like 5 minutes on this one, maybe 10 during a contest, and an hour on the next one. So it's not that I gave this one a proper time, but I'm not sure I would come up with a solution in half an hour. Maybe with a hint that, for example, the code is very short, or that this is very easy problem. Maybe that would be a proper hint.
Yeah, it's always an issue with these problems that like just require a certain idea after which it becomes simple. Like it's really an coder style problem. So with this, there's a lot of randomness in terms of how fast you can come up with the idea. You can come up with it in like 30 seconds, or you can think for an hour and have nothing.
Yeah. It isn't an issue for ICPC. Like in ByteDance camp, that one's for teams, right? Or not?
Yes.
Then you don't really care that much about difficulty. If you misjudge, just teams will solve another problem. In Codeforces, it is a big issue.
Well, yeah, Codeforces is much more time pressed than ICPC.
To summarize the solution, I will maintain the permutation of dimensions to know right now which one corresponds to which one at the beginning. Also, just for each of them, we keep the offset. Not really. We need to keep offset for the two of them, for first and second dimension, from the very beginning.
Well, we actually need to have all three, because if we shift something x-wise and then swap x with that, then the shift to x somehow carries over to z.
I see. Okay, so all three values will be needed for offset. Yeah. Okay, along the permutation, we maintain the offset set starting with 0, 0, 0. And we also need to then correspondingly swap it when we swap something in the permutation, because we swap two dimensions with each other.
Yep.
And at the end, go through all ripples and fill one value in the answer. That means we understand which two of the three values correspond to coordinates in the grid, row and column, because we know the permutation, and we put the value there in the answer, while understanding the offset, of course. So
exactly, yes.
Value printed to the answer is also added with some offset thing, modulo n.
Yes, it's really like when you look at the entire thing, it's like it's universal. You don't care about what is dimension and what is value. Everything is treated in the same way.
I agree. Just when reading the input and when printing to the output, you care really about one dimension representing the value.
Yes. So maybe a part of this problem is this equivalency, right? If you were just given a set of points in 3 dimensions and these transformations, you would probably notice the solution much sooner, right?
Oh yeah, no, the first step was important. Not maybe the first. The one where we treat value as another dimension.
Yeah.
Then it was obvious that we swap.
Yes.
I wanted to say something here. Oh yeah. One detail I didn't like in the statement was that numbers were from 1 to n, and rows and columns, because of those formulas, I minus 2 modulo n plus 1. It's so easier to just say I minus 1 modulo n and I plus 1 modulo n.
Yeah, I agree.
I would use from 0 to n minus 1. Everything.
Yeah, that would be more neat.
Well, okay, that was my favorite problem so far.
Okay, I'm really glad to hear that.
And flip and reverse. Even if solution is nice, I don't know if I will be able to like it, to appreciate it. Let's go through the statement. Then I will tell you my idea for a solution. I have a working and square solution.
Okay, good.
And I thought that I can improve it with a trip. So first question to you is, do you have a solution using a trip?
I think I can come up with a way to introduce trip, but the intended solution is linear time.
Right. It boiled down to reversing some intervals and maintaining information about them. I need to reverse n intervals. And in my brute force, the square part comes from, indeed, reversing. And then I need to quickly find any value, let's say, equal to something, because I know I will match with that one and I will reverse the thing. In
Yeah,
short,
so this kind of ideas, I see what you mean. So you're basically solving the problem in n operations. Right?
Yes, that's true.
And then the problem is to find like the endpoints of a segment that you have to swap. I'm not sure if like I didn't try too hard to implement this kind of solution, but I won't be surprised if it's possible after all.
All right. Statement first, or maybe second, because now we briefly talked about my slow solution.
Right.
In F, one operation on a substring is to take, if substring of a longer string has the same number of zeros and ones, then you can reverse and flip it. What does it mean?
Yep.
Well, first you reverse, that's the standard operation, and then you flip state of every bit from 0 to 1 and the other way around. That's what you can do with a substring. The other bits don't change. The problem is, given a binary string, you need to find the lexicographically smallest one that you can achieve with any sequence of operations.
That's correct.
String has length 500,000.
Yep. I wouldn't bet on the trip solution getting too far with these kind of constraints.
Well, I will tell you that I just tried to improve my brute force with some heuristics, so it would for sure pass random tests, but your tests were not just random, not random binary strings.
No. There are certain modifications of this kind of solution, like choose carefully with which subsegments to flip. And it's true that if you can't apply any operation to a string to make it lexicographically smaller, then you're done. So there are different strategies, and they require different counter tests. So there are a bunch of counter tests that make like some solutions have quadratic complexity and some just work really, really slow.
Mine was quadratic, and well, I will tell you my solution.
Okay.
It's not fully proved, but it's tested on like thousands of tests with brute force, so I know it's correct. I maybe don't fully understand why.
Yeah.
All right. So first completely unproved thing is that it's correct to go from left to right, and for every bit, if it's 1, I want to change it to 0 if possible. And turns out correct that I can find arbitrary endpoint so that substring would be good. Good meaning ones and zeros are the same count. And the last bit is 1 as well. By the way, lemma, simple lemma, if string has 1 and 0 at the endpoints, then it doesn't make sense to use this substring, because at the end you will have again 1 here and 0 there, because after reversing 0 goes here, then it's flipped, so it's 1. Instead, you can as well take the shorter substring.
That's true.
So that was simple lemma. And now something unproved is that actually I just take substrings with 1 at the beginning and at the end. Indeed, it makes this full string better right now, because it puts 0 at some left position. Maybe there's more stuff on the left. I don't know why only this would be enough. Maybe it's good to take something with zeros at endpoints to do an operation, and that would allow us later to do some smarter operation maybe on the left, and we would get even better string. I don't know why that's not... We don't need to consider it.
Well, I guess that it should be possible to prove. Again, I don't know. The proof does not involve like the change of mindset, if you will.
So just to visualize stuff, we're talking about the case where maybe it makes sense to change substring to something worse, lexicographically greater, but only then, because there are some other bits outside, say XYZ here, XYZ here. Only then, thanks to this change, we can do an operation for, say, this substring on those modified bits here, and then Y becomes a better character now, from 1 to 0.
Well, I'm pretty... I'm not sure of the direct proof, but it's kind of similar to the last problem. If you look at the problem in a certain way, I think a lot of things just become clear instantly.
We will eventually move there.
Yeah.
I will continue my solution, my n-square solution. Okay. So turns out that just go from left to right. For every one, I try to find any one on the right such that the string is balanced, ones and zeros are the same, and then do the operation and move forward. I tried taking the first such one or the latest such one. Both work. I can take an arbitrary one. I even implemented random shuffle on indices here, just to check if in this order I can prioritize them and basically match my one with random one on the right, if it's good. It also worked. We will maybe later understand why this works. So yeah, that's polynomial solution. I never get back, so just for every I, for every j, if balance is true, and those are ones, then the reverse operation, reverse and flip. This is quadratic, not cubic, because for every I do the reverse only once, because then 1 changes into 0. And I tried to move to the trip solution by taking prefix subs. The fact that balance of some substring is 0, if you represent every one as +1 and 0 as -1, means exactly that when you draw a graph with +1s and -1s, like in balanced bracket sequences,
yes,
you're interested in something like this. You start from some balance, now you go down below this balance, you do something here, and then you get back to this balance. So now if there is balance here B, balance here B, and you go up there, that's a 1. You go up here, that's a 1. Then you can do an operation here. Not only it makes it easier to make an if for my quadratic brute force, where maybe not really brute force. I know that I want to have the same level and the two must be ups, but also if we analyze this, the drawing will exactly be reversed, which surprised me a little bit, but I don't know if I have function in this program to reverse. The point is, after doing an operation, we will have looking from the left down, then this weird part I drew, then up, up, down, down, and we have this balance B. The same, just mirrored. I wanted to use a trip that would be able to reverse an interval, and given a value, it would find arbitrary equal value on the right, where value for me would be a pair of your level, your balance, and the last move, up or down. So actually twice n possible values instead of n, something like that. I don't know trips well, so I spent some time even reading on trips to think if I can do it. Reversing is possible. Just finding that arbitrary value equal to that, not necessary. This is where I ended.
My gut tells me you might have to use SQRT decomposition for that.
I also considered SQRT decomposition, but limits are quite high. 500,000 and time limit of 2 seconds.
That's true. That
might
doesn't
not
look
pass.
too good.
So I didn't want to split into buckets of size square root of n. I just wanted to maintain the last square root of n updates, being the reverses. And whenever I have some query, I go through them. And also once every square root of n queries, I recompute the whole sequence. So the sequence is computed correctly, with the exception of past square root of n queries. I thought about that solution, but thought it's too slow.
Yeah, could be.
Want to tell me the solution or the next step?
Okay, sure. So actually, well, the observation about flipping parts of the graph horizontally is what I initially had as the solution. Basically, you can think of when you cannot make these kinds of operations and stuff like that. And you can sort of arrive to the fact that there's a unique recombination of elements that can achieve that. But then in testing, the testers came up with a really beautiful interpretation, which made me like the problem even more.
I will just tell you here that the thing I drew for me was the case where I cannot make an operation for the starting point, even though it goes up. So the balance must keep being greater or equal than the starting one, can touch 0. Just once it goes below 0, it must stay there. But I thought about applying the same for other points inside to think about some string from which I cannot move. I failed to do so, to observe anything.
Yeah, it's a little bit tricky because the endpoints can get in the way. Okay, so
maybe
the balance is important, of course.
All right.
And like the graph of the balance, we can think about. So what we can look about when you have the operations, you usually think about what is preserved after every operation, right? So we've already established that we flip horizontally a segment that starts and ends on the same height. So what that means is, well, of course, like the number of edges is preserved, but also the number of times we visit every height is preserved as well, right? Because that would just happen at a different point in the graph after reversing.
I agree. If balance 5 appeared 10 times, it will appear 10 times forever.
Yes, we can actually go even further and think of the sort of the segments, the edges of the graph, right? So when you go from balance x to balance, say, x plus 1.
Do you want to say that I can almost arbitrarily reorder the balances? So I will always go down as long as I can finish this sequence at all? Which requires some inequalities.
In a nutshell, yes. I mean, the tricky thing is that you also have to arrive at the same balance at the end.
I see. Okay. But if I had some black box that tells me if I now move down and I have some remaining balances to hit and the final balance, black box tells me if it's possible to move there like that, then if it worked in constant time, then I would solve the problem.
I'm pretty sure that's true. A bit finer point would be that we can look at the transitions between balances as a sort of edges, right? So if we go from x to x plus 1, we say that this is an edge from balance x to balance x plus 1.
All right.
And we can see that even that is preserved. If you look at how many times each edge appears between any pair of balances, that is preserved as well.
I see. So the fact that I go from this up to some bigger balance, it also appears somewhere in the previous graph. That's not really this position. This peak is right here.
That's true.
This, I would say, well, it directly corresponds to that. It needs to have some match. So well, whenever we go the up, we also go down on the same balance, except for the difference between the starting and final thing. But here we have starting and ending balance the same. All right, I agree. The same number of times we move from x to x plus 1, before and after.
Right. So yeah, edges are kind of interesting, right? And we can sort of rearrange them. So how about we think about it like that? We have this set of edges, right? And we want to make them between different balances. So why don't we draw a graph that has vertices with different balances, and also all these edges, right, that correspond to all the transitions.
If some balance appears 4 times, should I draw 4 instances of that vertex?
No, we just have a single vertex for each balance, and every time we go from, say, 0 to 1, we draw an edge from 0 to 1, and there could be multiple edges.
I see. Yeah, I've drew something that I think is possible because I'm just drawing a path that starts in 0 and ends at -1. So the parity must be satisfied, something like that. For every vertex except for the interval from between starting and ending point, the number of in and out must be the same. This must be connected.
Yes.
Yeah, just those two conditions, and the interval from starting balance to the ending balance. Well, starting must be equal to 0. It must be like -1. Like in minus out must be 1, or the other way around.
Yeah. So that might ring a bell somehow.
Yeah, some kind of Eulerian cycle. Like in equal to out means that there is path through the whole graph, visiting all the edges.
Yeah, exactly. So the string, if you draw this graph, corresponds to a path that visits all the edges, and it starts and ends at prescribed vertices.
Well, actually, end is defined by the start, because once you choose the start and you follow the edges, if there is an algorithm to find any path from start to just anywhere, and the end will be defined because of
yes. That would be finding any path we can do pretty simply with a GFS application.
All right. And now we need to find lexicographically smallest path where every vertex gives us a value, and we care about those.
Well, we can think about what can happen to this path, right? So as we reinterpreted all strings as paths, so what happens in terms of paths if we flip something?
Something on 2 endpoints might change. This is reversing a cycle.
Exactly.
But a mountain that just goes up and then down cannot be reversed. So
It can. You just replace edges. Well, when you reverse a cycle, you replace all the edges with reverses, right? So a mountain is just two edges in opposite directions, so that doesn't change anything. You're technically allowed to apply an operation to a 0, 1, but nothing happens.
Oh, yes, yes. That changes a lot in all my thinking process. The fact that operation on 0, 1 is allowed. At the very beginning, I understood that operation on, for example, 0, 1 does nothing, so I'm not going to do it, while I think it would help me to allow this fake operation. I see.
Yeah.
Right? Then okay, it's reversing a cycle.
Yeah, so we can flip any cycle, and it's sort of a standard argument that if you can flip a cycle, if you can flip any cycle in an Eulerian path, then you can obtain any Eulerian path from any other. That's
Do we need to think with some linear algebra here? Like this is always some linear combination of cycles when we XOR by a cycle?
I think, yeah, that's one way of doing that. You can also go constructively, like see the first moment where the two paths diverge, and then the actual edges that you use differently, you should be able to reconcile them by looking at the further occurrence of one of the vertex in the other path, and then use the exact same cycle to flip. And so you can just go left to right. And I think that's exactly what your solution is doing, actually.
Yes, but I forbid the case of looking at mountain that only goes up and down.
Well, in that case, you just take the best transition possible, right? So there is no need to transform this kind of path further.
All right. I see the similarity, and for sure now I would understand more about my observations that I just confirmed with the brute force. All right. Anyway, we have this graph.
Right. So now, if we believe that any Eulerian path can be achieved from any other, then the problem is now to construct the lexicographically smallest Eulerian path.
I see. When 5 minutes ago I said that we just find Eulerian path with lexicographically smallest path of values and vertices, this is true only because of this thing with combining cycles to create any path. So from one path you can get the other by flipping cycles. And now we can use some greedy-ish algorithm where from a vertex I will go to the left. No, to the left? No, because those are balances. I want from a vertex to move to among neighbors, the lexicographically smallest one, so smallest value, assuming that I can still finish.
Yes, exactly.
Okay, and from here I cannot move to the left, maybe only if there is no way out. So there is
exactly. If you move in some direction, well, ideally, like you only want to check if you can move to the right, because if you can't, well, you're just forced to go to the left, right? Yes, we assume that there is some continuation.
Yeah. So if there is continuation, then we move to the smallest value.
Yeah. So if you go to the right, the possible issue, like the only possible issue is that we can't go back to the left because there are no possible edges that we can use to do that. So if you go from x to x plus 1, and there are no edges from x plus 1 to x, but the final balance is below x.
Is it about the final balance or just any balance that we need to achieve? not necessarily the final one.
Let's see. Yeah, it's more accurate to say that if there are any points that we still have to visit X or
then
below.
I agree. Just we are not done with balances up to X.
Yes.
Then I agree. If this red set is non-empty and there isn't edge from X plus 1 to X, then we cannot now use this white edge from X to X plus 1.
Yes.
So that's easy, greedy solution. If we understand, for example, I don't know, the minimum balance not yet visited, not yet fully visited, meaning every occurrence is done, and maximum 1. This is how I would implement.
Yeah, well, you can go in easier if you have to, if it's possible to visit something below X and you have to do that, then you can also go through X. So you can only keep track of, well, do I want to visit X once more? And ignore everything below that.
Yeah, I agree. Because we care about we prefer going to right versus left.
Yes.
Well, depends on the order, which one means 1 in a string, which one means 0.
Yep.
All right. It's a nice problem, not as nice as the previous one, where it was really amazing, single amazing observation.
Yeah. It's a bit more tedious than that.
I agree. Also worth more points.
Well, yeah, that's true.
I understand how you, thought that E is significantly easier than F by looking at solutions.
Well, yeah, it was a wild guess, but yeah, I guess they are comparable, at least in terms of like if you can solve one of them, then it's likely that you can also solve another one. I guess it's sort of similar skill set.
Right. Are there standings ready? I'm interested mostly in standings of Division 1. Yep. Tourist 1 with ABCDE in hour and 12 minutes. Nice.
Yeah, that's a good performance. Great performance.
Well, I will later read and try to understand and solve E and F. Well, I took a look at F because the statement is just so short.
Yeah, F I liked a lot, and like it was a conscious decision to include F, despite the fact it was most likely that nobody solves it in time.
You don't often see a jump from 2,200 points to 3,500 points. I understood during the contest that F likely is unsolvable because of that, the scoring suggested.
Well, I mean, there are people who like to go for really hard problem to score a lot of points early on. That probably didn't happen this time.
All right, then that's it from me. Thank you for a good contest, a very good contest.
Okay.
And I'm saying that even though I didn't perform well, that means something. All right, editorial is posted, or will be?
Well, not exactly. I'll get back to you writing that right now.
I will then check out E and F from Division 1. All right, thank you for joining me a lot.
Okay, thanks for having me. It was a lot of fun.
Cool. Wish to see more contests from you. To everybody watching, thank you for joining the stream, and see you next time. Okay, bye everybody.
Bye-bye.